Okay, here we are on the last part of day 33, page 9 of 10. Where is it? Right there, page 9 of 10. And we have some word problems. It says algebra problem solving practice at the top. Use guess and check to solve the following problems. Okay, these are general problems. They're not necessarily using quadratic formulas. So let's see how we can go about solving these. This is a good page to practice because it's word problems. It's the kind of thing you might encounter on your test. Okay, again, use pause a lot to try to figure things out on your own, to read it first, to try it first, only when you're stuck or when you want to check and see if you did it right. Then you can go back and watch the video for the video part. Okay, I'm going to start right on number 1. You do your pausing on your own. A number divided by 2 is equal to 12. A number, when they say a number, that's a variable, right? Divided by 2, you could write divided by 2, or you could write it like this. Divided by 2 is equal to 12. What number, when you divide by 2, when you take half of it, is it 12? Now we want to end up with x, right? How are we going to get x? We want to get rid of this divide by 2, so guess what? We're going to multiply by 2. 2 times x divided by 2 is equal to 12 times 2. Whatever you do to this side, you have to do to that side. And you can see the 2's will cancel. Sorry. The 2's will end up canceling because you're multiply by 2, divide by 2. You'll end up with x. X equals, what's 2 times 12? 2 dozen. 2 dozen eggs is how many eggs? 24 eggs. There we go. We'll try to do it on this paper. If not, I'll have to turn. Oh, I bet you I have room here. Yes, I do. I have a blank here. Okay, for a fundraiser, Sandra raised 3 times as much money as Barbara. Barbara raised 50 more than Matt. Together they raised $950. How much money did Barbara raise? Okay, let's say you tried the answers out. There's 4 answers. One of them's got to be right. Let's use this $200 one because it's got zeros. They're usually easier to work with. Okay, Sandra raised 3 times as much as Barbara. Let's put this. Well, how much money did? Let's say Barbara raised 200. Sandra raised 3 times as much money as Barbara. What's 3 times as much as Barbara? 3 times 200. Sandra will be what? 600. Barbara raised 50 more than Matt. Again, this is Barbara, and it's 50 more than Matt. How do we get Matt? Well, Barbara's more than Matt, so we have to subtract 50. How much did Barbara raise? Well, let's add them up. If we pick 200, 600 and 200 is 800. 950. Oops, we already found the right answer. C was the right answer. We guessed the right one. I picked 200 because it had zeros. The other ones look like they'd be a little harder. Okay, that's it. How would I do it in algebra? Okay, so this is number what? 2. So we want to find Barbara. Let's say B is Barbara. Okay? We know that Sandra raised 3 times as much as money as Barbara. That means Sandra is equal to 3 times Barbara. You could put 3 times B or just 3B. 3B is the same as 3 times B. Matt and Barbara raised 50 more than Matt. So if you want Matt, you would take Barbara's and do what? Did he raise more or less? He raised less because Barbara's 50 more. That means Matt is 50 less. We have to subtract 50. B minus 50. And there's our 3 people. Okay? Together, they make 950. So what do? You add these 3 things. B, can't see. B plus 3B. Remember, 3B is the same as 3 times B. plus B minus 50. And altogether, it makes 950. I'm going to add my B's. I got a B and a B. That's 2 B's and 3 B's. 5 B's minus 50 is equal to 950. Now, I want to end it with B, so I'm going to get rid of this 50. It says subtract 50, so what am I going to do? I'm going to add 50. 5B. Now, if I subtract 50 and add 50, it's going to be 0, so I'm not going to put anything here. I'm going to put equals. I got rid of the 50 by adding. In a way, I'm moving the 50 to the other side, but when you move it to the other side, you change the sign. It's going to be plus 950. We're removing this, so we put it on this side as plus. We're adding 50 to both sides. That's how we got rid of that 50, so we add 50 over here. Now we get 5B is equal to 1,000. How do we get B? We want 1B, so we're going to divide by 5, and that'll give us 1B. 5 divided by 5, 5 divided by 5 is 1. But that means we divide this side by 5. We end up with B is equal to 200. Now, always when you get the answer, check and make sure you found what you're looking for. I'm looking for Barbara, it says. What is Barbara's? And that's what we set, B equal to Barbara. So that's the answer, 200. My answer, way down here, is 200 because I said B equal to Barbara. Okay, that was the right answer. Okay, number 3. Again, try it on your own. Try pausing. The 3 packages below weigh a total of 15 pounds. First, second, third. Now they're giving it a little away here. They're saying 3 is probably going to be bigger. Then comes 1. Then comes 2 is the smallest. The first package weighs twice as much as the second package. The third package weighs 3 times as much as the second package. How many pounds does the first package weigh? Now, we could put the first package as X, but it says the first package weighs twice as much as the second package. That means we'll have to say the second package is 1/2 the first. I don't like using fractions. Let's make the smallest one X. Then these will be bigger than X. They won't be a fraction, hopefully. Okay, so we're going to call the second package X. I don't know if I can do it here. So let's say second is X, right? Oh, you didn't see it. Second is X. So then the first, now listen to what it says. The first package weighs twice as much as the second. So the first package is what? 2X, twice as much. The third package weighs 3 times as much as the second. Oh, this is working out nicely. The third is equal to what? 3X. How many pounds does the first package weigh? Well, I forgot something, didn't I? Go back here. The 3 package below weigh a total of 15 pounds. So we have to add up to 15 pounds. So the first one's, can I fit it here? Maybe. Let's try it. I'll have to write tiny. Okay. The first package is 2X. The second package is X, so I'm going to add it. And the third package is 3X. Equals 15 pounds. Now, 2X and 1X. Remember, X is 1X. 2 and 1 is 3, and 3 is 6 X's. Equal 15. But we want X. How do we get to X? We divide both sides by 6. 15 divided by 6. If you put that in your calculator, you might know that that's 2.5. But if you put it in your calculator, you're going to end up with 2.5. Right? Now, am I done? I don't know. What did we say was X? The second package. What does it ask for? How many pounds does the first package weigh? We figured out the second package is 2.5. What's the first? Well, the first is twice that, 2 times that. So you would have to go 2 times 2.5. If you put that in your calculator, 2 times 2.5, what do you get? 5.5. 0.0, but 5. 5 pounds. There it is. 5 pounds. And that should work out. Okay? Okay. Number 3. Hannah scored a total of 170 points on 2 math tests. The score of the first test was 6 points lower than the score of the second test. How many points did Hannah score on the first test? This is what you can do without algebra. She got 2 tests. The first test was 6 lower than the second test. How many did she score on the first test? So if these are first test scores, how would you get second test? Well, the score on the first test was 6 lower than the score on the second test. So to get the second test, you're going to have to add 6. So let's look at A. If that's the first test, well, I'm doing this without algebra. If that's the first test, let me move this a little, that'll make it easy. Okay, if that's the first test, because we want to know the score on the first test, to get the second test, we have to add 6, because the score on the first test was 6 points lower than the score on the second test. So the score on the second test is 6 points higher. 6 and 76 is 82. Now you add them. 76 and 82 you could put in your calculator. If you know 7a is 15 and you know 6 and 2 is 8, it's 158. Now, what do we want? 170. This was too small. Too small. You want to jump to 88? Let's jump to 88 and see what that does. 6 points higher, 6 and 88. You can count them, but it would be 94. Put those in your calculator. What do you get? Well, 8 and 4 is 12, so we're going to carry 1. I'll put the 2. 8 and 9 is 17, and 1 is 18. 182. Too big. It's got to be the one in between, doesn't it? What's 6 and 82? 88. 160. Oh, 8 and 2 is 10. 170. Ta-da! So you can do this one pretty easily just by trying out the answers. Okay, let's do it mathematically now. What is the first one? So we're going to call the first one F. The score on the first test was 6 points lower than the score on the second test. So the second one is F plus 6. And when you add them together, F plus 6 equals 170. 2F plus 6 equals 170. I subtract 6 from both sides. 2F equals 164. I divide by 2. F equals 2 and the 16 goes 8, 2 and the 4 goes 2, 82. 82 is the first one. Got it? That's how you do it algebraically. Okay. Number 5. This is taking longer than I thought it would take. Number 5. Nelson is twice as old as Maria. 6 years ago, Nelson was 5 times as old as Maria. How old is Nelson 6 years ago? Okay. Let's do Nelson's age now. We'll call it N. Just to make it simple. Start. That's now, not 6 years ago. Now. When we get the answer, we're going to have to take N and subtract 6 because we want to know how old he was 6 years ago. So N is Nelson's age, right? Nelson is twice as old as Maria. So Maria's is what? Maria's is going to be N over 2. She's half as old. Nelson's twice as old as Maria. So if he's 10, she's 5. Got it? She's 10. By the way, you could try this one out with these numbers and see if they work. How old was Nelson 6 years ago? We could try that out. That's you almost know it's got to be an even answer because if you do 6 years ago, if he's 5 now, if he was 5 6 years ago, now he's 11. And 11 is twice as old as Maria. Maria would have to be 5.5. So we know the odd ones can't work because you get it. Maria would be a half year old, and I don't think we want that half years, right? So you could try 10. If he was 10, well, we can do it that way. Try it out. Do you want to try him out? Okay, if Nelson was 10 6 years ago, how old is he now? 16, right? Well, you know what? We can make a graph here. We're going to make a graph. Nelson, Maria. And we're going to say now, and then say then. Then means 6 years ago. Okay? Now, let's try the 10 in here. If Nelson's 10, how old was Nelson 6 years ago? So that was then. Nelson was 10. Let's say he was 10. That means now, that was 6 years ago. Now he's 16. He's twice as old as Maria. How old would Maria be now? 8, because she's half of him. You know what? I'm doing all this and you can't even see. What I did is I made a little chart here. Nelson and Maria. This is now how old they are now, how old they were then, 6 years ago. So the question is, how old was Nelson 6 years ago? So if we start with 10 6 years ago, that means he's 16 now. And he's twice as old as Maria. That means Maria must be 8 now, because Nelson's twice as old. How old was Maria 6 years ago? You take away 6. She's 2. Nelson was 5 times as old as Maria. Is that 5 times? 5 times 2 is 10? Yes, 10 worked. Now, why couldn't I use 5? I explained it, but I'll show you. If he was 5 6 years ago, he'd be 11 now. And 11 is twice what? Half of 11 is 5.5. I don't think we want halves. That's not going to work. For the same reason, 15 won't work, because you're going to end up with 21 years old. Half of 21 is like 10.5. We don't want halves. 20 would work here. If he's 6 years ago, he's 26 now. Maria would be half, 13 now. Take away 6 should be 7. 7 and 20 is not 5 times. Okay, let's do this algebra now. Number 5. We're going to do it the algebra way. So let me write it here. How old was Nelson 6 years ago? Let's say Nelson is n. Okay? Nelson 6 years ago was n minus 6. Maria now is half of Nelson's age. So this is Maria now is 1/2 n. Or we could put n over 2. How old was she 6 years ago? N over 2 minus 6. Now what do we do? Well, we know that n over 2 and n minus 6 and n over 2 minus 6. Oh, we know this. N minus 6, 6 years ago, n minus 6 was equal to 5 times Maria's age back then, which is n over 2, half of his age now, 6 years ago, minus 6. There we go. That's our equation. N minus 6 is how old, what's his name? Nelson was 6 years ago. Maria was n over 2, half of his age now, minus 6 years ago. 5 times that was Nelson's age 6 years ago. Okay, now we can do it. Let's see how we're going to do this. We got a fraction here. I don't like that, but we're going to have to work with it. N minus 6 is equal to 5/2 n minus 30. Because you have to do 5 times minus 6, right? Now we want the n's on this side and the numbers on this side. So I'm going to add 6 to both sides, and I'm going to subtract 5/2 n. So now we have n minus, we're going to take away 5/2 n is equal to minus 30 plus 6 minus 24. What we should have done is we should have moved the ends this way and the 30s this way. Okay, let's do that instead. Go back. We're going to add 30 to both sides, and we're going to subtract 1 n from both sides because 5/2 n is actually bigger than 1 n. Then we'll end up with positive numbers. So we end up with 30. We add 30 to both sides, and we subtract an n, so the n disappears. It goes on the other side. 5/2 n plus n. 30 minus 6 is 24. Now 5/2 n is the same as 2/2 n. 2 over 2. So you get 5 and 2, you get 7/2 n. This is the same as 2/2 n. So we can add 5/2 and 2/2 and get 7/2 n. Now how can we get rid of the 7/2? We're going to multiply, are you ready for this? We're going to multiply by 2/7. And I'm going to get the wrong answer somehow. Okay. Anyway, multiply by 2/7, we get 2/7 times 7/2 n. These cancel and make it n. But this becomes, oh, I forgot this, 2/7 times 24. And that's not going to work. What did I do wrong here? 5/2 n minus 30. I add 30 to both sides. I get 24. That sounds right. I subtracted n. I didn't add n. I subtracted n, not add n. So you got to go back and find your mistake. I was supposed to subtract n. So instead of adding 2/2 n, I'm subtracting 2/2 n. That gives me 3/2 n. Now, I want 3/2 times what? 2/3. And that'll give me 1. That means I was supposed to multiply by 2/3. That's going to work. Okay. 2/3 times 24. You can divide 3 into 24 and get 8 and then multiply by 2. Or you can multiply 2 times 24 and get 48 and then divide by 3. Either way, you're going to end up with 16 equals n. You could do that on your calculator. 2 times 24 divided by 3. 16 is equal to n. Now, what is that? That's how old Nelson is now. And the question was, how old was Nelson 6 years ago? So you got to subtract 6. 16 minus 6 is equal to 10 years old. Wow. Wow, wow, wow. Okay. Try number 6 while I take this phone call, unfortunately. I can't talk. I'm in the middle of taping a math lesson. Who is? Okay, I'll talk to him. Bye. John, she can hear you, and it's waking her up. So stop talking to the mirror, please. Okay, here we go. Did you try number 6? Those are simple domestic problems. You have one 24-year-old child talking to a mirror. You have the other 20-year-old sleeping at 11:30 in the morning. Typical domestic problems. Okay, did you try number 5? Oh, number 6, sorry. Okay, which of the following is the solution for the quadratic equation? Where am I? I'm looking at the wrong thing. Which of the following is a solution for the quadratic equation 2x squared plus x minus 15 equals 0? So you could solve the quadratic equation, or you could just try the answers. Now, 1s are easy numbers to use, but it's a -1. But let's use it anyway. If we put a -1 in there, we would end up with -1 squared is actually 1, not -1, because a negative times a negative is a positive. 2 times 1 is 2, plus minus 1, which means subtract 1, is 1. Minus 5 is not going to be 0. No way. How about the 2? 2 squared is 4 times 2 is 8. Plus 2 is 10. Nope, minus 15 is not 0, so 2 doesn't work. So it's got to be 3 or negative 3, right? Let's try positive 3. 3 squared is 9. 3 times 3 is 9. Times 2 is 18. Plus 3. Nope, going to be too big. We want it to be 15. So it's got to be minus 3. Minus 3 squared is 3 times 3 is 9. And the minus times the minus is a plus. So that is also 9 times 2 is 18. But you're going to add negative 3, which means subtract 3 is 15 minus 15. This one works. How would we solve this? Well, we want to try to factor it. So we do this, remember? And one of them has to be 2x, and one of them has to be x. And we want to do 5 and 3, right? 5 and 3 have to work. But it's a negative, so one's going to be minus and one's going to be plus. If I put the 5 here, I'm going to end up with 5x and 6x. That's actually going to work because I'll have 5x and the 3 over here will be 3 times 2 will be 6x. And if you subtract them, you end up with 1. So that's what we're going to do. Put a 5 here and a 3 here. Now, we want it to be minus 5x. This one's going to be 3 times 2, 6x. This one's actually going to be bigger. Usually we just take the bigger number, but because this is a 2 here, it's going to be 3 times 2. This is going to be the bigger one, so that gets the minus, that gets the plus. Now, which one works? Well, you know what? I didn't get it right here. I did something wrong because my answer here is 3 works. Oh, I'm sorry. I want plus, not minus. I want 3 times 2 to get the plus, and this one to get the minus. Another mistake here. That one gets the minus. This one gets the plus because I want 6x minus 5x will give me plus 1x. Okay, now, which is an answer? X plus 3 could be 0. When is x plus 3 0? If x is minus 3. Anyway, that's how you do it with algebra. Wow, we're really running out of time. Number 7, an amusement park sells adults and children's pass. An adult pass is $25 and a child's pass is $15. A group spent $440 on 20 passes. How many children's pass did the group purchase? They bought 20. Why don't we just, well, we can't use 10 and 10 because there's none that's 10 here. What would be a good one to use for which one? You can just try it and see which one works again instead of doing the algebra. Okay, it got 20 passes. How many children's? Okay. Well, I'll tell you one way to do this, see how much they spent on average. 20 into 444 is, if you divide that, you get $22. So they spent really close to the adult amount, not close to the children's amount. That means there has to be many more adults than children. So let's start off with this one, 5. Let's say they got 5 children. You would go 5 times 15. What's that? If you put in your thing, you get $75. Now, if they got 5 children's passes and they got 20 altogether, how many have to be adults? 15. 15 times what? 25. What's 15 times 25? 375. 375. And if you add them together, what do you get? 5 and 5 is 10, 7 is 14, and 1 is 15. $450. Wow. 450. I want 440. I spent a little too much. So I'm going to have to get rid of an adult and add a child. Now that was 5 children. So if I get rid of an adult, adults cost $25. If I get rid of an adult ticket and buy a children's ticket with it, I save $10, and that's what I want to save is $10, right? So I'm going to get rid of adult and buy another child. Before I said 5, so now it's going to be 6. See how I got that answer? I tried 5. It was a little too much money, so I had to get rid of an adult ticket, going down to 14, and add a child. I didn't really have to multiply again because I know every time I get rid of an adult and add a child, I get $10 back. Okay, how would you do it no, now the other one's yelling out too. How would you do it in algebra? Well, I'll do it over here. So, I'm going to say my children's tickets, I'm going to get X children's tickets, right? An adult will be 20 minus X because there's 20 tickets altogether. I'm not even showing you. Here we are. A children gets, I'm going to buy X children tickets and 20 minus X adults. So when I figure out how much that costs, I go, children's is $15 times X. That tells me how much my children tickets cost, plus $25 times the price, how many adult tickets, which is 20 minus X. Altogether, it's $440. You see how I got that? I got X children's tickets, so $15 times X children tickets tell me how much I spend on children. If I got X children's tickets, I got 20 minus X adult tickets, and they cost 25. When you add the two parts up, you get 440. So this is 15X plus 25 times 20, 500. 25 times minus X is minus 25X. Is equal to 440. Now, okay, if I do this, I'm going to end up with minus 10x because it's got 15x minus 25x. I'm going to end up with minus 10x plus 500 equals 440. So now I'm going to add 10x to both sides, and I'm going to subtract 440 from both sides. So I get 500 minus 440. In a way, I moved it over to the other side, but you subtract. I'm going to move this to the other side, so I have to make it positive. I'm adding 10x to both sides. This is 60 equals 10x, and then you divide by 10, and you get x. The number of children's tickets is equal to 6. Ta-da! You see how I got that? Okay, one more to go. The rectangular garden below is twice as long as it is wide. If the total distance around the garden is 120 feet, what is the width of the garden in feet? So, they made this one pretty easy. Let's call the width W. Well, I can do it here. Let's call the width W, right? The length is equal to 2W. The perimeter, which is the distance around, is you just add the four sides. So you're going to get W plus 2W, but then you're going to get W again and 2W again. Oh man, I'm not showing you anything, am I? Boy, I'm really having problems here. Okay, repeating. Here's the width. The length is 2 times the width. I want the perimeter, which is the distance around, so I go W plus 2W plus W again plus 2W again. All together, that's 120. W and 2W is 3W. W and 2W, 3W. 3 and 3 is 6W is equal to 120. How do you get W? You divide by 6. W is equal to 20. The width, yep, the width is 20. It didn't ask, if it asks for the length, we have to say 40, twice the width. But it asked for the width, 20. Okay, that's it for our word problems. I hope you're able to do some of those without much help. The less help you need, the better you're going to do on the test. So again, always try to do as much as you can do without help. That's it for now. Okay, on to lesson 34.